Hello everyone. So today you are going to be introduced to something called HDL, which could be most probably new to you all. Uh, to be specific, we'll be looking at Verilog HDL. Now you might be wondering what this HDL means. HDL stands for Hardware Descriptive Languages. So this is kind of like a programming language that we are using to model digital circuits. So today in this part of the session, we'll be looking at an overview of digital design with HDL, or to be specific, digital design with Verilog HDL. Now for this Verilog HDL, we have a reference book which is called a Guide to Digital Design and Synthesis by Samir, this author. And you can refer to this reference book if you need to get additional information or knowledge regarding Verilog HDL. And I'll be uploading this book to Fields as well, so that you can have a look at it if you want. Uh, Now, before going into HDL or Verilog HDL, we'll briefly look at the evolution of computer-aided digital design and why it became important to come up with something like HDL. Uh, so, if you consider small circuits with just hundreds of transistors, now it's sometimes okay. I mean, it will not be that complex to design the layout on paper or by hand on a graphics computer terminal. And you can test that circuit on a breadboard as well. Once you are designed and implemented the circuit, you can test a small circuit on a breadboard, just like we did it in the digital design labs. But if you consider a modern processor like Intel i7 processor, it has millions of transistors. Now, to be specific, Intel i7 has this number of transistors, 731 million transistors. So a circuit like this, you cannot easily design on paper or by hand, and you cannot test this kind of a circuit on a breadboard because it's a complex circuit. So to design and implement these kind of circuits, computer-aided techniques have emerged. Now, HDL is like a prominent one of the prominent techniques that have emerged to design and verify digital circuits using computer-aided techniques. So now we'll briefly look at how HDL emerged. So if you consider programming languages like C, now they describe computer programs which are sequential in nature. So things happen one after the other. So it generally is not designed to perform parallel operations. But if you consider digital circuits or any circuit, they involve a lot of concurrency because things in nature, physical things in nature, happen concurrently or parallelly. So the general programming languages are not suitable for modeling these kind of digital circuits, because if you consider just a simple circuit that has two AND gates, and then the outputs of these AND gates are connected to another OR gate. So if you consider the signals that traveled, or the inputs that traveled from input to output, they travel independently and parallelly. Like if you consider one AND gate, it operates independent to the other AND gate. and they are operating parallelly, and the output of these two AND gates are then fed to the OR gate, which again is acting independent of others. That is like they are all working in parallel concurrently. So, to model something like this, uh, it was unable of. If you think about it, you will realize that it's really hard to model something like that with a programming language like C. Now, the languages that were designed to describe these kind of digital circuits are called hardware description languages, or hardware descriptive languages, and they came into existence because of the reason I mentioned just a little while ago. So now in this part of the course, what we'll be looking at is how you can use HDL to design and verify circuits, digital circuits. Okay, so we'll now look at how the integrated circuit design uh, process works in brief, of course, because digital circuits are, at the end of the day, they are going to be manufactured as integrated circuits. So the integrated circuit design procedure, we'll have to look at it if you are going to design them. So the first step of this integrated circuit design procedure is the formal and precise description of a complex circuit in an abstract level. In an abstract level, you will describe the behavior of the circuit. So that is the first step you need to do when you are going to design an integrated circuit. So design and implement a integrated circuit. And the second step is automated analysis and simulation, which is about analyzing the circuit you already have designed and simulating the design simulating the design to check whether it's functioning as we want. And once you are done with these two steps, so now you have the design and you have verified that the circuit is functioning properly based on simulations, and now you can go for implementing this circuit, that is physically implementing the integrated circuit. Now before implementing this circuit, the first thing you need to do is synthesizing this into a netlist. So these words like synthesis might be new to you. So the synthesis process is a process that we use to generate a circuit out of a model like one described in HDL. When you go into details of HDL, you will understand it better. So you first describe the circuit in a hardware descriptive language like Verilog, and then you get the need of converting this into a real circuit, like generating a real circuit out of a model described in HDL is called synthesis. So the automated synthesis into a netlist is the third step of design procedure of integrated circuits. So the netlist is about the specification of electronic components and how they are connected. And this is like a specification, what are the components that are needed to build this circuit, and then how they should be connected with each other to get the desired functionality. And this is the netlist. So at the end of the third step, you get that netlist, and once you have the netlist, you can use this netlist to place the electronic components and route the wires. So this is also done in an automated way. Like this also can be done in an automated way. When it comes to a complex circuit, something like a processor, these things are done in an automated way. There are tools that are designed for this purpose. Once you are done with placing and routing, you can send that design directly for fabrication. Anyway, in HDL, we will be focusing on the first two steps of the integrated circuit design procedure, because the last two steps will not deal with the last two steps when you are doing something in HDL. So in fact, there are tools that are designed for the purpose of generating an net list and placing and routing components. So there are tools. If you have the design written in HDL, then you can easily use that design to get a real circuit by using automation tools. So in HDL, what I wanted to say was, like in HDL, we'll be looking at the first two, we'll be focusing on the first two steps of the IC design process. Now, if you look at hardware description languages, there are multiple options that you can go with. So it's like if you consider software programming, you have multiple options for the programming language that you need to use, things like C, Java, Python, things like that. So in HDL also, you have multiple options. So two widely used HDLs are Verilog HDL and VHDL, and there are other less commonly used ones, AHDL, HPL, BlueSpec, things like that also are there. But the most commonly used HDLs are Verilog HDL and VHDL, and out of these two also, we'll be looking at Verilog HDL, how you can describe digital circuits with Verilog HDL. That's what our focus is. And if you look at the brief history about Verilog HDL, this Verilog HDL was invented in 1983 at Gateway Design Automation by Philip Moby. And so the HDL is like a program, kind of like a programming language used to describe digital circuits, as I told you earlier as well. And synthesis process, we use it to convert a circuit described in a language like Verilog to a netlist. So the first Verilog based synthesis tool was introduced by Synopsys in 1987. And then the Gateway Design Automation, which invented Verilog HDL, was bought by Cadence in 1989. And also Verilog placed in public domain to compete with VHDL somewhere later. And this Verilog is standardized by IEEE, Institute of Electrical and Electronic Engineers. And this Open Verilog International OVI IEEE 1364 was standardized in 1995, and then in later years the standard was a bit like it was revised, and then these other two standards were generated. So this is like a brief introduction to the history of Verilog HDL, which might not be very important when we are going to design circuits with Verilog, but just for your information, I talked about this as well. And if you further look into Verilog HDL, the benefits and the different ways of using Verilog HDL, the main benefit is that it's easy to use. So if you look at the syntax of Verilog HDL, you will see that it's very similar to syntax of C programming language, but you need to keep in mind that things in Verilog are not happening similar to what you see in C, so that also you should keep in mind, but you'll realize it later when we go into details of how you can do designs, digital designs with Verilog. We'll come into that later. And Verilog supports mixed level modeling. So it has, like, when you are going to design a circuit with Verilog, you have multiple options like you can model, you can use behavioral modeling in Verilog to uh, design a circuit. And there's another way called data flow, and also you can use gate level modeling to design a circuit in Verilog. So in behavioral modeling, it's more like what you see in C. In a algorithmic form, you can describe how the circuit should work. In data flow modeling, you will be describing circuits in register transfer level. In this course, we'll be mostly focusing on gate level modeling. So in gate level modeling, uh, you will be designing the structure of the circuit using basic gates like and, or, no, that you already have seen. So in this course, we'll be focusing only on gate level modeling in Verilog. Other two methods, you will be looking into them, especially computer students, you will be looking into them in upcoming courses like CO224 computer architecture. And another benefit of Verilog HDL is that it can be used both for design and simulation. So it's a single language that can be used for design and simulation. So how you can do this design and simulation, we'll look into it later. Uh, and it also has built-in primitives, logic functions, data types, things like that are available in Verilog. And also you have the option to have user-defined primitives. And also it has built-in high-level programming constructs. So things like if conditions, loops, things like that you can use in Verilog. So these high-level programming constructs mostly are used in modeling techniques such as behavioral modeling. Okay, now this is like a brief overview of HDL and Verilog HDL. In coming parts, we will be looking at how you can design a digital circuit using Verilog. Thank you.